Hey, I'm here trying to loop it. Lol. Anyway, I want to show the effects with the multimeter. So I have my pulse motor hooked up through my choke transformer rig. Okay, this is my power supply coming in. This is the motor feed going to the H bridge. Here's my diode. My multimeter set to direct current. Hot lead is to the hot of the power supply. Negative lead is from the motor, so we could watch the voltage in its cycles. And then I've been trying to loop it, see if it'll do anything. Just fooling around, but I didn't expect that to work, but it doesn't. Anyway, let's get the motor up to speed. Watch the speed up process on the scope. It's coming up now, starting. And here's the speed up on the scope and back down. Okay, now, right now, the power supply has more voltage than the motor side, but it's going down. Now on speed up, it went to negative. This side has more power now, 6.4 volts, and we're only putting in 6. The motor side gets more than 100% the voltage of this, so the voltage doubles. Negative and 14. Scope is going to start going up. Boom, scope goes up to 6 volts. Positive again. This side is now hotter than the motor, but now it's starting to switch, and 0. This side is hotter, up to 6, 7, 8, something like that volts hotter than the power supply. And that's when it starts stalling out, because the back EMF, the voltage goes so high, the amperage goes so low. Watch the amperage. The amperage goes down to like nothing on slow down. Now watch on speed up. Here comes speed up any second. Now 0.9, almost 1 amp on speed up, no amps practically when it's winding down. So when it's winding down, we have more voltages on the hot, and when it's speeding up, we're putting amperage through the choke, and it's starting to speed up. Boom, 6 volts more than this side on speed up. Now if you're measuring between a negative, that would be 12 volts between here and here, even though we're putting in 6. So quite fascinating. This is my generator coil. I have a bridge rectifier hooked up, and this is coming out of the bridge rectifier, the positive. The negative's already hooked up to the negative lead. So I've been trying to wait until we get the right there and connect it. Now we're still getting our speed up and slow down, but now it's happening much quicker. It's a good question why. I could try to explain it, but anyway, we got the same effect. It's happening much quicker when we're putting more voltage into here. Now I've been trying to unplug the hot to see. The H bridge is still pulsing. It's giving it enough to pulse that H bridge for a while, but it peters out. It won't continue, and the H bridge is dead. Not enough voltage. Anyway, some fairly interesting stuff going on. So just so you see, I'm going to put this side on the negative terminal. Watch. Now it's even more interesting, believe it or not. Oh, yeah, it's on this side. We gotta put it on this side. There we go. 6 volts, 7, 12, back to 6. Power supply is only putting out 6, but it's feeding back in, so the display is changing. 12, 11, 6, 12, 6. It doubles its voltage, no doubt about it. When it speeds up, it inducts into the choke and the voltage doubles. Yeah, 6 more volts. You get double the volts here than you do as the input. So it doubles the whole voltage going in per se. And it's going the right way, because if it was inducting against us, it wouldn't be jabbing it up like that. It would be fighting it, bringing it down. But it doesn't. It's like nicely in phase. But I've been drawing it out on paper, trying to figure out exactly why this is happening, but I'm not sure. Anyway, those are my trails. If I take this side, okay, I took the bridge rectifier and I put it on the motor side. 7, 8, 9, 10, 11, just about 12. It's doing like the same thing. Now let's try to unplug. I think it's still going to need this input, but now it's taking a lot less power to do that. Look, it's taking a lot less power. Now we unplug it, see if it'll power itself, and it won't. It's petering off. Still making that H bridge barely pulse, and the H bridge is dead. Now this far in voltage, I'm assuming is just voltage from this capacitor hanging on to the last little bits of juice. Anyway, that's my video for tonight. Just wanted to update, show that I'm still poking around with it and getting closer, maybe not, but either way.